What if I told you that the next major earthquake might not begin beneath your feet, but nearly 150 million kilometers away? A violent explosion on the surface of the sun triggers invisible waves. Hours later, the ground beneath us shifts. It sounds like a science fiction, but this isn't conspiracy theory. This is real science. And today we are diving into the one of the most controversial and misunderstood question in the geophysics. Can solar activity trigger earthquakes on Earth? The answer will blow your mind. Now let's start with something unsettling, a pattern that scientists have been noticing for decades. In 2004, just days before the 9.1 magnitude Indian Ocean earthquake, the sun unleashed a massive solar flare, one of the strongest in modern records. And in 2011, the Tohoku earthquake in Japan, again preceded by elevated solar activity and geomagnetic disturbance. Coincidence? Maybe. But there are hundreds of such correlations documented across decades, too many to comfort. And while correlation doesn't equal caution, it raises a burning question. Could solar storm be whispering a warning before the earth roars? Let's break this down. The sun is constantly releasing energy through solar flares, coronal mass ejections, and high-speed solar winds. When these particles strike Earth, they disturb our planet's magnetosphere, a shield of magnetic force that protects us. These solar storms can cause geomagnetic disturbance known as GMDs. We have already seen their power. They knock out satellites, disturb power grids, affect animal migration, but here is where it gets fascinating. Recent studies suggest this disturbance may penetrate deeper into the Earth crust itself. But how does something in the sky shake the ground? Now let's talk science. Researchers have proposed three key mechanisms that could link solar activity to seismic events. The first one is electromagnetic coupling. Intense solar storms can induce electric currents in the Earth's surface. These currents may alter the pressure within fault zones, especially those already on edge. And the second one is magneto-hydrodynamic effects. The Earth's core is electrically conductive. When GMDs hit, they may subtly stir the molten outer core, disturbing tectonic stresses from below. And the third one is ionospheric interactions. Solar radiation can heat the upper atmosphere unevenly, affecting atmospheric pressure, which in turn may influence tectonic plate movement indirectly. Now to be clear, most scientists don't believe the sun causes earthquakes directly, but growing research suggests it may act as a trigger when fault lines are already critically stressed. And in earthquake science, even a small trigger can mean the difference between silence and catastrophe. Despite the compelling correlations, the idea remains controversial. Mainstream geologists argue that tectonic plates are primarily driven by forces inside the Earth, not outside it. But space weather scientists have a different take. In 2011, a study published in Natural Hazards and Earth System Sciences found a statistically significant correlation between geomagnetic storms and earthquake clusters. Other papers have tried to replicate these findings with mixed results. So where does the truth lie? Like dark matter or consciousness, we are at the edge of what we know, and sometimes those edges are where the most important discoveries happen. And here's the real question: if solar activity can trigger earthquakes, could we predict earthquakes by monitoring the sun? Imagine combining real-time solar observations with seismology. We already track space weather minute by minute. If we could correlate it with tectonic stress data, we might one day develop an early warning system, not just for solar storms but for earthquakes. The sun is more than just a life giver. It controls our weather or electricity or satellites, and maybe, just maybe, it can whisper warnings from across the void before the earth quakes. So the next time you hear about a massive solar flare, remember, the ripple effect might travel deeper than we ever imagined. So if you found this as fascinating as we did, hit that like button, subscribe for more mind-bending space science, and turn on notifications. And in next video, we'll dive into the one of the most stunning solar phenomena ever recorded, solar prominences, those glowing loops of fire that stretch across thousands of kilometers of space. But what exactly are they, and why do they defy gravity? Tap here to watch the next, because the sun's secrets are just getting started, and I'll meet you in the next video.